Glad you're joining us today because this episode is about to go nuclear. We're going to be talking about quantum physics with a nuclear physicist, Ben Davis. Can something be both a particle and a wave simultaneously? What the hell does that even mean? After this show, you'll be able to understand it. Episode 42 of the Right to Reason podcast, your chance to completely nerd out with your host, Robert Stanley, starts right now. Quantum Physics with Dr. Ben Davis.
The cosmos is also within us. We're made of star stuff. We are a way for the cosmos to know itself.
And let me assure you that we are going to take our fight for economic justice, for social justice, for environmental sanity, for a world of peace.
We must guard against the acquisition of unwarranted influence, whether sought or unsought, by the military-industrial complex.
One aspect of American U.S. life and culture that I think that does deserve respect and admiration is protection of freedom of speech. The U.S. is unique in the world in that respect.
Hi, this is Dr. Ben Davis, and you're listening to The Right to Reason.
After Ben tries to science me in the face, I ask him about pseudoscience, and he tells me something that blows my mind. I actually believed in junk science, and I never even knew it. That's how this stuff seeps in. You just accept it because you've heard it over and over and over. I couldn't believe that I was susceptible to this junk just like everyone else. You might be too. Give them a listen and leave your presuppositions at the door. Within the next hour, you'll come away with a little humility about your conception of the world around you. Before that, I want to remind you that you can find other episodes and videos at our website, therighttoreason.com. If you have the opportunity to promote our message, share us with your friends, or support us at patreon.com/right. Are you ready to have your mind blown? Stay tuned for the end of this broadcast because Dr. Ben gives us his personal ghost story. It's time to exercise your right to reason. Let's ride.
Culture is not your friend. Culture is for other people's convenience and the convenience of various institutions, churches, companies.
We very naturally, as a cognitive and behavioral imperative, we form descriptions of the world and we try to figure out what's going on.
If you base the design of rockets on science, they reach the moon. It works. Bitches.
Ben Davis has a PhD in nuclear physics and an MS in nuclear astrophysics from the University of Notre Dame. He taught at the college level for several years on a number of technical subjects ranging from computer programming and math, astronomy, physics, you name it. Late 90s, he took up a career in software and industrial controls engineering. That's like robot programming, stuff like that. As a lifelong fan of science fiction, his main avocations now involve history, futurism, and skepticism. So he's welcome on this show, that's for sure. He'll fit right in with the listeners. When not traveling with his wife, playing with his dogs, climbing rocks, or attending cons, he spends his spare time pondering general relativity, the search for extraterrestrial intelligence, and the effects of antimatter on dark matter or dark energy. Sometimes he haunts for true psychics, ghosts, and other paranormal phenomena to no avail. Dr. Ben, happy to have you on, man.
Glad to be here.
I think you might just be the smartest guest I've ever had, and that says a lot. So it's a little intimidating. I hope just in asking questions I don't sound too stupid. Just in the way that I ask it, because a lot of this stuff is way over my head.
Well, I'm sure we'll tarnish your expectations in the next hour or so.
Yeah. Well, what really got me thinking whenever I was looking into you and learning more about you, and just before we get started, if anybody else wanted to learn more about you, where can they find this information at?
Oh, that's easy. I'm easy to reach. If you're on Facebook, you can just go to facebook.com/AskDrBen, run it all together like one word, and you'll come right to my page.
I saw that you were big into quantum computing. It reminded me of when some media guy tried to bust Trudeau and tried to embarrass them and say, "Well, I'm sure you don't want to." Well, hold on, I'm just going to play it.
I was going to ask you to explain quantum computing, but when do you expect Canada's ISIL mission to begin again? And are we not doing anything in the interim? while we prepare.
Okay. Very simply, normal computers work by... Don't interrupt me. When you walk out of here, you will know more. Well, no, some of you will know far less about quantum computing, but most of you, normal computers work either there's power going through a wire or not. It's 1 or a 0. They're binary systems. What quantum states allow for is much more complex information to be encoded into a single bit. A regular computer bit is either a 1 or a 0, on or off. A quantum state can be much more complex than that because, as we know, things can be both particle and wave at the same times, and the uncertainty around quantum states allows us to encode more information into a much smaller computer. So that's what's exciting about quantum computing, and that's what
I love it. I wish we had a smart guy running our country.
Well, yeah, good luck with that, right?
So a lot of that was over my head, especially the part where he says something can be a particle or a wave. How is that even possible? Can you help us out with that?
That's the good old wave-particle duality, and that was an amazing response, by the way. You almost kind of wonder if you're a little cynical if that wasn't somehow practiced, because it's just amazing the kind of clarity he came out with. 30, 45 seconds to respond to that? It's just not the kind of thing I would expect a let alone, a layperson, but a non-physicist to come up with, or somebody that wasn't deep into quantum computing even.
Yeah.
But wave-particle duality is really the very heart of quantum physics. It basically says that everything is a wave on some level. And you don't necessarily notice that with big objects like, let's say, a big red rubber ball or something, but it's a packet of waves. It's a collection of a bunch of atoms, and it's a packet of a bunch of waves held together. And it has a fuzzy boundary on it. So if you think about this red ball and you think about the edges of it being fuzzy, the only reason that we don't think about that in our day-to-day is that boundary is so tiny compared to the size of the ball. So it might only be, let's say, a couple of nanometers wide. Well, you're talking about a ball that's, say, 3 centimeters wide. You're not going to notice a fuzziness on the border that's a couple of nanometers wide. You start talking about an atom or especially an electron, something really small, then there's nothing there but the fuzziness. So that wave character starts to come out and exhibit itself way more in a way more obvious way than what it does with macro objects. Is that helping at all?
No. Well, don't get me wrong. It is very helpful. It's just, okay, I'm drinking a cup of coffee right now, right? The cup that's in my hand, are you saying it's not really hard, or at least made up of hard stuff? It's actually just a bunch of waves?
That's exactly what I'm saying to you. It's not as solid as you think it is.
I mean, that I can get. Like, I'm fine with accepting that it's just all atoms and that sort of thing. But my brain says, okay, here's something that's a solid object, but it's made up of lots of tiny little solid objects. That's why it's solid. That makes sense to me. But whenever you say it's not even really that, Robert, it's really waves. Okay.
I've often said that the mistake in thinking for most people in quantum mechanics is that they think they have to look at objects and think of them as waves. The truth is that everything's a wave. And our mistake in thinking is to think that most of the stuff we see is solid objects. Now, of course, some people might take exception to that because they said, no, it's in the real world, it's a solid object. Macro world, it's a solid object, because it's a collection of a bunch of atoms, a bunch of wave packets, right? So that collection adds up to something that feels very solid, but it's still just a bunch of waves superimposed on one another. A bunch of probability waves.
So, it's like when you talk like this, or if I'm reading an article, about some quantum mechanic thing, it's almost like it starts to get like fantasy talk almost. It's so beyond my comprehension where I just have to. It's like whenever somebody says, "Well, space is eternal," or something like that, or dark matter stuff. Or it's just like it's so far beyond, I guess, my intuitive understanding of how things are that I have to just kind of go, well, okay, sure. I guess so. But I'll just accept it. But it just doesn't feel, I just don't feel comfortable with this idea. That makes it, I don't know if that would make sense to a guy like you. Like, you've been studying this your whole life, so whenever a layman like me is talking about it, it probably sounds wacky coming back at you, but.
Not at all. I think it was Erwin Schrödinger that said, if you are comfortable with quantum mechanics, you obviously don't understand it. It makes everyone uncomfortable, including the physicists. But the experimental, evidence bears it out. You start taking an electron and you start running it through a crystal lattice, and it gives you a diffraction pattern just like running light through a diffraction filter. And you can even do it one electron at a time, and this thing will still build up this diffraction pattern, maximums and minimums, dark areas and bright areas, right, and fringes, like a wave going through a slit. And there is no analog to that.
Oh, is this that double slit thing that you're talking about?
Absolutely. Can
you explain that to me? 'Cause I've always wondered about that. I even had a guy on. He was telling me that aliens exist and he's been abducted, and he was out there, right? And he starts talking about, oh, well, things aren't really as they seem. And he tried to use the double slit experiment to argue that, science isn't really science, or it's some kind of loopy stuff.
We'll come back to that, I'm sure, when we start talking about pseudoscience. Unfortunately, a lot of people that don't know anything about quantum mechanics still, call back to it to justify whatever they want to believe. And of course, that's not how it works, right? But the double slit thing, it's a little hard to describe just in audio. Pictures help a lot. But you can take, let's say, a swimming pool and take a board and start bouncing the board up and down, right? So that you're making waves in the surface of the swimming pool.
Okay.
Then you can put a wall across, let's say, the shallow section of the swimming pool. Use a little rope or whatever that they keep the kids out with, right? And you cut little slits in it, right? And what's going to happen is that wave is going to stop everywhere at that wall except where those two slits are. It's going to make two little waves going through those slits. And those two little waves are going to interfere with one another when they hit the walls of the pool. And there's going to be areas where there's double the size of the waves. And there's going to be areas where there's no waves at all. It's just flat water. And that only makes sense if you think of this thing as a wave. If you start to set up a BB gun and try to shoot it through two slits in a target, the BB's always going to end up in two maxima spot, right? That's directly behind the slits. You're not going to shoot the BB gun at these two slits, at the center of these two slits, and have the BB go to the middle of the back plane, right? It's always going to be right behind where the two slits are.
That makes so much sense.
Yeah, so the solid objects don't do that. Waves do it all the time. Solid objects don't, because waves scatter their energy or disperse their energy, and then they can put them back together behind boundaries in ways that solid objects can't do.
I've never heard it described that way before, but that makes a lot of sense. That actually makes more sense than the videos I've watched on it. Just you describing water like a wave or a particle with the analogy of the BB. That makes perfect sense.
Yeah, so, and it's crazy, but it works. And that's the thing. It makes a lot of people uncomfortable, including scientists, which is why I became a nuclear physicist and not a quantum physicist, right? Because I had a hard time even wrapping my mind around it.
Well, now I know. Now I know quantum mechanics, so.
Fortunately, you can treat atoms pretty much like they're solid objects when you run them through a particle accelerator, so I didn't have to wrap my head around that very often.
So whenever they were doing that, speaking of that particle accelerator, that was identifying a field, right? It was like the Higgs boson field. That was what that particular test was at CERN.
That's going into high energy physics. And so you're talking about particle physics. You're talking about getting way up there in energy ranges. The stuff I played with was about 6 orders of magnitude less energy than that. So when you start talking about those kinds of particles accelerators, you start talking about Fermilab and CERN and things like that, you're actually smashing things together so hard that you're breaking them into subatomic particles, and you're looking at what's coming off. In the case of the Higgs boson, the energy of the collision is so great that you're actually making equals mc squared, right? You're actually taking all of this energy from this collision, and you're looking for evidence of a new particle being created out of all that excess energy flying around. So that's way up there. What I did was I would hit atoms with other atoms and watch them bounce off and figure out how big they were.
Fascinating.
Yeah.
Is the kind of stuff you were working on, does it give you a clearer understanding of the Big Bang? You know, that's another topic where I have to go, okay, I'll accept what you're saying, but it's just a little bit over my head kind of stuff. You know, I do a lot of debates on the show, and that's a typical question that I get. Well, what was before the Big Bang? How did the Big Bang just happen? If there's nothing and then there's a bang, where'd the bang come from and stuff like that? And I have logical answers to that sort of thing, but trying to really explain or understand the science of it is pretty intimidating.
Right. And, you know, there comes a point where anybody that's got any sense at all will just tell you, we don't know. Right.
Right.
I mean, there are theories, of course, but, you know, all we can observe is the fact that everything in the universe is flying away from everything else, like shrapnel from a bomb, it's this Hubble effect, right? And that's what people can actually observe experimentally. We've also observed the background radiation from the explosion, air quotes on that, but we know that there's residual energy left from some sort of explosion. We know that everything in the universe is pretty much flying away from everything else. And we know that it flies away in proportion to how far away it already is from you. And if you stop and think about that for a minute, it makes perfect sense because it's receding at a certain speed and it's a certain distance away. And if you play the clock backwards, it means that everything goes back to one point in space at some time, about 14 billion years ago, right?
Okay.
So it's literally like, you know, like the plum pudding and the raisins in the plum pudding. As this thing expands, the raisins get further and further apart. They start out close together. They're still close together. But the ones on opposite ends of the plum pudding from you get way far apart and are in the expansion are getting farther apart at a much higher speed. But they all go back to some central point when you play the clock backwards. That's what we know. When you start asking, what initiated this Big Bang? Where did this matter come from? How did it all get kicked off? How would we ever know that, really? And again, in case you haven't picked up on it yet, I'm an experimentalist, not a theorist. So if I can't stick it in a particle accelerator and measure it, then I start to say, well, that's cool, but that's a nice theory, right?
Right.
You have to be able to prove that in some way. And I don't know how you'd ever prove this whole parallel universe thing or the oscillatory universe, which basically argues that the universe is always there. It just goes through these big bangs and big crunches and then restarts itself. It's fun to think about that stuff, but we really don't know because anything that happened before the Big Bang was destroyed. We have no evidence of it. I mean, it's all, you know, it's like what the bomb looked like before it exploded. You're probably not going to be able to ever figure that out with what you got left to work with, right?
That makes sense. I like how you use the plum pudding example too, because that helps. I was trying to explain that concept. I wish I would have had the plum pudding analogy available at the time, but I was arguing with Kent Hovind about this on one of the episodes, and I was saying, well, it's really not that point A and point B are moving apart. It's that the space between them is increasing. And he says, that's the same thing. That means they're moving. I'm like, well, no, it's just that the universe is increasing. The space within the universe is increasing, and that's what's making these things move apart. And I could have used that analogy. I think that might have helped a little bit. I'm not sure. But I found out in that same interview, he's an anti-vax guy. And that kind of, what's that?
I said, oh dear Lord.
Yeah. But it stuff like anti-vax or anti-GMO or, what's another one? People always send me stuff about the fluoride in the water.
Flat Earth.
Flat Earth. Yeah. Or dietary supplements are always safe for you. And, you can do your genetic testing at home. You know, all this kind of stuff. My brother he's a preacher and he just called me the other day and said, oh, I found out exactly all of my, genetic history and the whole line of everything. And, you know, I ordered something online and I did it myself. And I was thinking, it sounds a little weird. I'm like, so you found out we're all from Africa then? And, you know, he does it. He's a young Earth creationist. And so he's not going to believe that. So I was shocked that he would do that. He goes, oh, no. It just said I'm from England. We're actually, you know, from a long line of royalty and stuff. I'm thinking, oh, this doesn't add up at all. Is there something that all this junk science stuff kind of has in common that we can identify it just before we have to go through the long process of researching every single new thing that comes along, you know?
Well, you know that at the bottom of it, somebody's making money off of it. I mean, there's two major motivators, and the two aren't mutually exclusive, right? One is somebody's going to be making money off of it. Another is probably a religious, underpinning. You're trying to prove a certain belief that you have, and this flat Earth thing, or this, what's another good example?
Lizard
creationism
people.
thing. Yeah. They're trying to go back and say that the Bible is literally true, which I think every sane person, even in the 1800s, gave up on that notion, but somehow this is coming back around now, right? So there's always an agenda behind it. There's always something that somebody wants to believe. It goes back to something somebody wants to believe, and there's somebody that's wanting to sell that to them so that they can make money off of them and encourage that belief system.
Well, what do we say whenever they throw that same stuff back at us, and they, someone, like Donald Trump says, well, global warming isn't really real. I wish we had some of that global warming in the East right now, like that some tweet he just made recently about,
right.
Because it's so cold.
Right. Every time a snowflake appears somewhere, it's like, oh, well, see, global warming's not real.
Yeah. But their argument is often kind of like what you're saying, though. It's similar in the sense of they'll say, yeah, but this is just a way for people to institute a carbon tax, follow the money, and you can see that global warming's a scam. What's a good response to that? Because that's, I always am like, well, maybe there is some money behind it, but that doesn't necessarily make it false, right?
Right. I mean, there's money behind a lot of stuff. I mean, there are people that made their livings, that made their fame and fortune, on selling us oil and doing all kinds of things, petrochemicals and GMOs and all that stuff. Somebody made money off of that. So there's a motivation for them too. The difference is that, I think they actually come up with real results that actually help people in the long run. And that goes back, and that's one of the things that's insidious about a lot of these pseudoscience, junk science type things, is that they are accusing the rest of us of doing exactly what they're doing. Mm. And they're saying, it's the it's big oil that's really screwing us over here. And yeah, maybe, but I think back in the 1920s when people realized that they could drill oil out of the ground and put it in the cars, they probably didn't understand that was going to cause a problem 100 years later.
Right.
People were just happy that they could get in a car and go from point A to point B in a quarter of the time, than they used to. So we all bought into it. We all believed it. We all didn't necessarily see the long-term effects of that. And now it's time to do something about that. Vis-a-vis global warming. We all make mistakes, but the collective all made that mistake. These French guys, they want to start their own collective, but most of us don't buy into the fact the world is flat. And it's pretty easy to go and do the research yourself and prove that wrong if you just have to, but unfortunately there is something to be said for just going along with the mainstream. Things are the way they are for a reason. And it got the mainstream support it got for a reason.
Even though the flat earth thing is so ridiculous. Just for anybody that wants to do a little more than just laugh and roll their eyes at it, what's just some easy ways that we can know the earth isn't flat?
Oh, goodness.
I can't believe I just asked a nuclear physicist that question on my show.
Well, that's a whole nother discussion. I mean, I don't get to do nuclear physics very often anyway. I mean, I ended up being a computer programmer most of my career. So, I always end up talking about something else other than what, I was necessarily trained to do.
That's my fault.
I have, and again, this is where I kind of wish we had visuals. I have a gorgeous time-lapse photograph of an eclipse where you can literally see the outline of the Earth as the moon passes, in different phases, or phase is a bad word when you're talking about the moon. The moon passes at different times, and it makes a wonderful circular shadow on it as it's passing. It's a partial eclipse. It makes a wonderful circular shadow on it. If you come to the Ask Dr. Ben page, I'll find the picture for you. You just got to ask.
You sound like a round Earth shill right now. That's what this is. You're trying to promote the NASA lie.
Well, and I've heard him say that there's nowhere on the planet that you can go and see that the Earth is curved. It always looks flat from every vantage point. So one of the things I did when I did a talk on it was I went and found a random photo of some dude on top of Mount Everest, right? Somebody took a snapshot of him. And I literally drew tangent lines on the edges of the picture. And I could show that there's about a 3-degree difference in the tangent line on the left versus the tangent line on the right. So it's not a flat line even from the top of Mount Everest. You can see the curvature of the Earth. Not only that, you can do the math and say, oh, the angular acceptance of the camera is this, 3 degrees is that, therefore it's a, 200 and something mile picture of the horizon, and then you can do the math and you go, hey, that works out to 25,000 miles circumference. And you can do that, and I've heard people argue that, well, okay, maybe it's a circle like a CD-ROM or something. Maybe it's a flat circle, but it's still not circular in 3 dimensions. Well, again, you can do this from any mountaintop that's high enough. You can do this from any building that's high enough, and you can see the curvature of the Earth. Every vantage point, every direction you look, it has that curvature. If you just look for it, draw the tangent lines, and do the math. People knew this even 2,000 years ago. One of my favorite stories to tell when I teach astronomy, which I don't ever get to tell anymore, because, the school I work at doesn't have an astronomy program. But there's a fellow called Eratosthenes. He was curator of the Great Library. And he literally knew that the Earth was round. This is something like 200 BC. But he already started with the premise that the Earth was round. People knew that. Sailing ships would go over the horizon. The last thing you saw were the tops of the sails, right? So people took it as a premise that the Earth was a globe even back then. But one of the things that Eratosthenes put together was that there was this city called Syene, several hundred miles to the south of him. And on the day of the summer equinox, they had this really deep well, and you could literally see the reflection of the water down in the bottom of that well, but only on that day. So the sun was directly going over that well, and you could see the bottom of the well, but only on the day of the summer solstice. So, because he knew that fact, he went out and he measured an angle of a spire that stood straight up, the shadow, and he found that it was about 7.2 degrees, the shadow at the maximum of the solstice. So he knew that there was no shadow cast in Syene. He knew there was a 7.2 degree shadow cast at Alexandria to the north, a few hundred miles away. He sat down and he calculated the circumference of the Earth by hand.
Wow.
And got within 2%, depending on, who's translating the book and what their definition. He used something called stadia. And so what their definition of a conversion from stadia to miles is, he still got, even in the wildest estimates, he was only off by 5% in his estimate. And we're talking like 220 BC here. People have known the Earth was round for all of modernity. This is not something that's anybody struggled with for generations.
Is there like other junk science-y things that we might not even know or are junk science, that are just common colloquial things that people just say?
Oh, Lord, yes. Don't even get me started on nuclear physics. Every time I see anything about Fukushima, I about lose my mind because they're saying all kinds of crazy stuff that just doesn't make any sense to anybody that understands anything about nuclear physics.
But what do you mean? The Fukushima thing, doesn't it's we're getting radiation from it even over here in the States, stuff like that?
Right. It's like polluted the oceans to the point that the salmon are infected. And
yeah.
All this crazy stuff.
I thought that was true.
Not exactly.
Okay, cool. I'm all ears.
One of the things they quote is cesium-137, and they talk about how the cesium-137 levels in the ocean are at some high that they've never been at before. And this is easily debunked. You don't even have to know that much to realize just how crazy that is. First of all, nuclear reactors don't generally make cesium-137 as a byproduct. Secondly, they did all the atomic testing. The United States did all the atomic testing, Bikini Atoll and all that stuff back in the 50s. And cesium-137 is a byproduct of atomic bombs and hydrogen bombs. So we polluted the oceans, to be sure, and we did it back in the 50s and 60s until they put a ban on atmospheric testing. The cesium, and there's about just as a point of reference, there's about a 30-year half-life of cesium-137. So we stopped testing nuclear bombs over the Pacific Ocean what would that be? Let's say we stopped in I think 50 years. I think it was right about the time I was born, 1964, maybe 1966, but somewhere around that, about 50 years ago. Half-life cesium-137 is about 30 years. That means there's about a quarter of the cesium-137 in the Pacific Ocean now than there was 50 years ago. They're trying to tell us that Fukushima has put so much cesium-137 in the ocean that there's more of it now than ever before. It's getting in the salmon and it's going to kill us all. That cannot be true. That simply cannot be true. It was deliberately might be a stretch, but it was put en masse into the oceans 50 years ago. There's less of it now than there has been in 50 years since we started atomic bomb testing. And the salmon didn't kill anybody 50 years ago.
This is one I really believed, and you just blew my mind. So we're okay. The Fukushima thing, it's not slowly killing everyone.
It's a tempest in a teapot. I mean, even the city where they've evacuated, the nature has taken over there. The wild boars have moved in and taken over, and there's all kinds of large animals that are living there and thriving because there's not any humans there to compete with anymore.
So what's the difference between something like that and like Chernobyl? Like that one was kind of what Fukushima's...
Chernobyl was a disaster of an epic level, and there's no excuse for it. And there's a lot of story behind Chernobyl too. Where do we start with Chernobyl? Chernobyl was a graphite moderated reactor. Most of the reactors, any commercial reactor, as a matter of fact, in the United States and most of the rest of the world, is water moderated. Now, why did the Soviets build a nuclear reactor and Chernobyl actually had, I think, 4 reactors in its larger complex there? All 4 reactors were in this really big building. And there was only one reactor that melted down. But why do they use graphite instead of water to moderate the neutrons in that reactor? Well, it turns out that if you use graphite, then you can get a little bit of plutonium out of the waste products. So they were using the reactors as what they call breeder reactors to make plutonium so that they could maybe have 1 or 2 more atomic bombs to aim at the United States. This was in the middle of the Cold War, right? So they made this really fundamental design flaw into this reactor, and even that wasn't bad enough to cause the problem. They started doing tests on the reactors in the middle of the night. They absolutely shut down the safety systems, and they wanted to see if the reactor would do what it was supposed to do with half the safety systems disabled.
Whoa.
And when things got out of control, they couldn't get it back in control before the sarcophagus, or the sarcophagus is the wrong word. That's what they're covering up with now. But before the pressure vessel actually blew up on the thing. So now, if we go back to our basic chemistry, we know the fire triangle, right? Nothing blows up or nothing catches fire unless it's got a source of oxygen, a source of fuel, and a source of heat. So you got a reactor pile, nuclear reactor pile that, I don't know, probably wants to naturally sit at something like 2,000 degrees as it does these nuclear reactions in this pile. We have graphite, think coal, pure carbon, right? Something that burns easily. And now we see that this pressure vessel has exploded, so fresh air is hitting it. So now you have this pile of graphite that's going to catch fire, guaranteed to catch fire, make radioactive smoke, and because it's heated by a nuclear source, it doesn't matter how much water you dump on it, the thing's just going to relight. The water's just going to turn to steam, and the thing's just going to relight. And the only thing you can do is to sit there and wait for this thing to make all the smoke it's going to make and burn itself out, and probably go through a meltdown while it does it, which it did. It melted down into the basement of the facility, and it's called the elephant's foot. I found a wonderful article on that. There's still this pile of spent reactor fuel in the basement of Chernobyl that will literally kill you if you stand in front of it for more than 30 seconds. That's how radioactive it still is. But that whole thing was so badly designed and so badly done, there's no excuse for it. And that really, as a nuclear physicist, that makes me very sad because it drove the last nail into the coffin of the nuclear industry. And it's also why we're all choking to death in our greenhouse gases now, right? If we've been generating power with nuclear for the last 40 years, we wouldn't be having this problem we're having with global warming.
Wow. I'm still processing everything you said. That's
yeah, this is
fascinating.
my soapbox. You found my soapbox now. So
What other junk science stuff is out there that we could reference? Because I've already found out that I actually believed in junk science. You just blew my mind with that. I had no idea.
Oh, so I gored one of your oxen without even trying, huh?
Yeah, which is awesome.
Well, I can tell you that when I did, one of the most profound things about this junk science talk when I first did it, is what started me on the whole junk science thing. The idea was came from a fellow named Stephen Malloy, right? And he actually wrote articles in newspapers and things like that. He had a column called Junk Science. And, that's a cool idea, and there's a lot of it out there. One of Stephen Malloy's soapboxes is DDT. He'll tell you that, it was a mistake to ever outlaw DDT to kill mosquitoes because mosquitoes carry malaria, and there's been hundreds of million people that have died in Africa because of the international outlawing of DDT. I bought into that. I believe that. It's the fact that Malloy said this that sort of got me on this tangent. And I started doing the research, and when you do the research, you've got to, look at both sides, right? And the whole DDT thing comes from a woman that wrote a book called Silent Spring back in the 70s. Her name escapes me, but we can look it up if you're curious. And she was right. She was right that this DDT gets into the environment. It infect is the wrong word, but it gets into the food chain, and it causes lots of problems and causes lots of cancers, including, the eagles having eggshells that are too thin, and they're not able to have eaglets because the shells break apart before the embryo can develop. So it was having this horrible impact on the environment. And to make bad matters worse, the mosquitoes, they're kind of like cockroaches, right? They're insects. Mosquitoes, being mosquitoes, end up breeding a resistance to them after you kill off a few generations of them. So DDT was not the answer. You can bring it out. You can use it for, say, 10 or 15 years. And then even if you're talking about Africa or South America, you have to put it away because it's leaching into all of the environment. And you got to let this stuff work its way out of the food chain again before you use it again. And that's okay because the mosquitoes have already developed a resistance to it anyway, so you might as well start using something else. So I'm the one that had to backpedal on that one and say, I thought I'd be on this rant about DDT, and it turns out that the whistleblower on that one was completely right, and Stephen Malloy was the one that was wrong about that. So it's part of, why the internet, conflates everything and confounds everything, right? Every argument has two sides, and you can't really know for sure without doing your own research. But like we talked about earlier, you can't take every little thing that the earth is flat, that the earth's only 8,000 years old. You can't research all of that and refute all of that to the nth degree. You have to use your common sense or ask somebody that you trust, that has already done the research on it.
You have an example there of a time that you believed in something that wasn't accurate. You did the research, you found out you were wrong, and you just move on. And that's what we do in the skeptical community. And I think that that's cool that even a physicist like yourself goes through that kind of same experience.
It's not the only time either. I mean, until about 4 years ago, I actually was on the other side of the global warming thing.
Oh, really?
Yeah. And again, it's doing the con things and doing the panels and the talks. There was one particular con that every year I was invited to sit on a panel about global warming. And the whole tone of this particular con was that global warming's not real. So, finally, by about the second or third year, I was invited to sit on this panel again, and it's like, if I'm going to keep sitting on this panel instead of just making snarky comments, once every 5 or 10 minutes, I need to really research this and find out. Well, I went and looked, and it's like, holy crap, this stuff really is a problem. Yeah. And I thought that it was, I was actually, if you talked to me 5 years ago, I would have told you it's actually hubris to think, when you look at Krakatoa or Tambora, these huge volcanoes that erupted 100 years ago or so, and spewed these tons of, carbon dioxide, everything else into the atmosphere. I would have argued that it's hubris to think that man could have had that kind of impact on the atmosphere the same way that a supervolcano could. But holy cow, we've done it. We've managed it. And that's part of, you got 7.5 billion people on the planet. They all want to stay warm when it's cold outside. They all want to drive their cars or their motorcycles to work. Even if you live in India, you probably got a motorbike.
Interesting. Speaking of skepticism, I always feel that it's kind of like the junk science thing is a lot like the paranormal stuff in a way, where researching it, you have to be open to changing your mind about commonly held beliefs.
Absolutely.
I was researching you a little bit, and I understand that you've been going around, you're kind of like a James Randi kind of guy, where you go around and you try to get these folks to produce some kind of paranormal evidence to you. And
in my wildest dreams, I'd like to be like James.
Well, yeah, but it's similar in a way. And I was hoping you could tell everybody your ghost story before I let you go, because I thought that was really cool.
So I was about 14 years old, and I was carpenter's aide at the time, lied about my age, told the boss I was 16, that kind of thing. And I had gotten on with my brother, who was the main carpenter on this restoration of this house way out in the country. And wouldn't you know it, it's out there isolated way out in the country. It's got these really steep angled roofs on it and whatnot. And it kind of looks like the Amityville Horror House, which was popular back in, let's say, that would have been 78 or so. So, I remember even looking at my brother going, this looks like the Amityville Horror House. And there had been some other carpenters that had quit, not because it was, they might have used, that it was spooky as an excuse, but it was a big job. I mean, this house had been abandoned for something like 60 years. So it was going to be a lot of work to restore it. But anyway, it was around the Memphis area. It was during the summer. It was 100 degrees in the shade. And so we got real clever, and we decided we're going to run these spotlights up on the roof, and we're going to come back in the middle of the night, and we're going to shingle these tar shingles on this roof when the sun's not beating down on us. Because it was just, you can imagine how miserable it was to try to shingle that place in the midday heat. So we went out there at 11 o'clock at night after the sun had gone down and everything had cooled down considerably. And we literally thought we were going to do like 8 hours of nailing shingles, by a spotlight, in the middle of the night on this roof. And it had temp in electricity. There was basically one junction box with one circuit breaker in it that the power company had run out there so that we could run electric saws and things like that. And we had set up, I don't know, let's say 8 spotlights on the roof the day before. And so we went out there and we turned on the circuit breaker and the roof lights up and we go, cool, this is going to be awesome. So we climb the ladder, we get to the top of the roof and we get ready to work. We get our hammers out and bang, circuit breaker pops. And we go, wow, that's weird. So now we're having to crawl down this steep roof in the dark, in the pitch black dark, find the ladder, try not to break our necks, get back down, reset the circuit breaker. So, we manage to not, break anything while we do it. And we reset the circuit breaker and we go back up on the roof. And about the time we get into position to start working, circuit breaker pops again. And it's like, this is crazy. So remember, it's the middle of the night. We've already heard some stories about this place. And so, our minds are already working 100 miles an hour, right? So we go down one more time, we reset the circuit breaker, the lights come back on, and we sit and wait for a minute, and it's like, okay, it's all right. It seems to be okay now. And we get up there, we get back into position one more time, and the circuit breaker pops the third time. And we're like, something's going on here. This can't be coincidence. And it's like, we're totally freaked out at this point. It's like, we're done. So we crawl back down one more time, reset the circuit breaker. We go back through the front door of the house with all the lights on. And I see this shadow against the wall. And my brother says I just stopped and turned white as a sheet. And it looked all the world like a man in a top hat, just standing there looking out the front door at me.
That's crazy.
Oh, yeah. Now, again, it's just a shadow, right? There's nothing to explain, air quotes on explain, the shadow that's looking straight out the front door at me. Now, the other thing you have to realize is houses of that age, farmhouses like that, usually the stairs that went up to the next higher level are right there inside the front door. So I froze. I turned white as a sheet. My brother's like, let's get the hell out of here. And I wasn't able to move. But in that 2 or 3 seconds that I wasn't able to move, because I was literally terrified, I noticed that this shadow's not moving. It's not talking. It's not saying anything. It's just this static thing on the wall. And so finally my higher brain kicks in, right, before I take off running down the road with my older brother. And it's like, wait, this is this is okay. This is just a shadow. This is not a ghost. This is not something I should be freaked out about.
It's that top hat that makes it spookier, too.
Oh, yeah. Well, and the part I didn't tell you is the 60 years that the house was abandoned. You know, this would have been like 1920 through about, let's say, 1980. And, you know, they said they had a bunch of hobos and homeless people live in that house for a time. And so it looked sort of almost like an era type, you know, what somebody that would be dressed to the nines would dress as, you know, and you instantly think, oh, this guy probably died in this house and he was probably very successful and he ended up being homeless. So you come up with all kinds of narratives that fit the whole top hat, you know, with a nice collar and all of that. But what we had done is we had put a 60-watt light bulb in one of the windows in the front of the house. So it became this point source of light that shone against the banister of the stairwell. And it was just the post, and it had this lovely crown molding that had, you know, all of this intricate curvature carved into it, right? So when you set a light in that window and you cast the shadow of this crown molding against the wall, it looks like a guy in a top hat. You see the eye sockets. He's in profile, right? You see the eye sockets. You see the nose. You see the lips. You see what looks like a chin. And it looks all the world like the shadow of a person. But it was nothing more than just a light bulb projecting a shadow against the wall of the staircase. And the funny thing about that is my brother, who's, you know, highly excitable, he was 8 years older than me, but still liked to tell stories. And for years after that, he would constantly tell that story to the family like we'd seen a ghost out in this farmhouse in the middle of nowhere. And I would always have to correct him. And I'd have to say, now, you know better than that. You know that we figured out what was going on. You know that there really wasn't a ghost. You know that we went out there in the middle of the night, we freaked ourselves out, and that's all there was to it. And we ended up hanging out, getting our tools and everything else for a good half an hour after that, and nothing came and got us. So stop acting like this ghost chased us away from this house. And, you know, I'd have to call him on that time and time again. And so that also, I bring that up because that also gets into the whole storytelling thing and how we all love to have an interesting story to tell, whether it's actually true or not. And I think a lot of people tell these stories and they even believe it. They even convince themselves that it really happened that way. And if there's not somebody there to say, wait, dude, I was there too. I saw the same thing. That's not what happened. And there's not anybody there to moderate that. And this person is believable. I think that's the very heart of where most ghost stories and where most myths come from.
It doesn't sound like your brother is like this inherently dishonest guy. I'm sure he's a great guy. But he's telling this story, and you're reminding him, you know, like you said, every couple of years when you hear him tell it or something, hey, remember, that was a banister, that wasn't a ghost. But it's like he keeps forgetting that fact, but remembering the interesting part of it.
Right.
And what is the difference, do you think, between, not necessarily just like you and your brother, but kind of in that same thread, but the difference between those of us that are believing in things that aren't real and those of us that are more skeptical? Like, what is it? Do they just want it more, or what?
It could be that. I mean, my brother, he's dead, by the way, because he smoked like a chimney until he got cancer, and the cancer metastasized into his brain. And, you know, he didn't make it to 50. So wow. Literally the last time I saw him, he wanted to see my new car that I'd bought. And I met him at the hospital. He was in the hospital getting treatment. And literally the last time I saw him, he's standing there with an IV stand in one hand and a cigarette in the other. And I said, dude, you are the biggest dumbass I have ever seen. You're literally dying from cancer and you're still smoking a cigarette. So he had this, you know, sort of addictive personality to begin with. I actually watched a TED video last night on hypnotism, and the guy was actually sort of debunking hypnotism, but he was actually talking about how certain people are prone to it. Certain people can go into like a dream state more readily than other people can. And he pointed out that he tried to hypnotize the whole audience. And, you know, he said, okay, if you fell asleep, then come up on stage. So he very selectively picked about 8 people out of an audience of, let's say, a couple hundred, and he brought them up on stage. And these were the most susceptible to suggestion types in the entire audience. And then he did make them get up on the stage and walk around like a chicken and do all kinds of crazy stuff because they were more, what's the word I'm looking for? They were more easily convinced that things weren't real or weren't exactly, the way that other people perceived it. It's a personality type. It's not necessarily a bad thing because I think a lot of creative people, touch into the dream state and it actually, makes them good artists or whatever.
Yeah. Okay. Kind of that helps explain this lack of skepticism. It has its use. It does have a benefit, but it also has some detriments too, and we're all just different.
All right. It's like Richard Dawkins said, for millennia, there was a time where if you heard that rustle in the grass, you assumed it was a tiger. You didn't stop and look and investigate. You got the hell out of there. And there was a very good evolutionary reason, why you did that. Yeah. So your mind automatically jumps to the tiger, whether it's really a tiger or not.
Dr. Ben, I have thoroughly enjoyed this last hour of talking to you, and I hope we could do it again sometime. If anybody wants to hear you go on more about all this crazy science stuff some more, how can they learn more about you?
If you Google Dr. Ben blows shit up, you'll go right to my YouTube channel. You'll see me actually doing experiments with explosives and whatnot. And then, of course, there's facebook.com/AskDrBen, which is where I take these kinds of questions and have these kinds of conversations online all the time.
Fantastic. Thanks for your time today, Doctor.
Thank you. Hope we get to do it again soon.
Dr. Ben is so chill, and I loved picking his brain today. If you have any questions for him, hit him up at Ask Dr. Ben on Facebook. He's literally the smartest person you now know, so take advantage of that resource. Next week, we will be talking to someone that needs no introduction. You know him, you love him, you wish he was your dad serving you pancakes on a Saturday morning while you watch cartoons. Okay, maybe that's just me, but I love this guy so much. Dan the Man Barker. Dan Barker. I'm looking forward to having him back on this production. But between now and then, doubt junk science. Doubt religious dogma. Doubt political diatribe. But never doubt your right to reason.